Hey everybody, this is Larry. This is day 3 of the July Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Yeah, happy Sunday or Saturday night, depending on where you are. It's Saturday night for me. And the contest is in about 2 hours for the Leetcode. So if you're doing that, good luck. If not, give me all your luck for now then. Alright, let's go. Today's problem is Rico. Subsequence. Okay. It's a sequence where the difference between successive numbers are strictly alternating between positive and negative. Okay. So it means that the numbers don't even matter. It is just positive or negative. Okay. And this is a subsequence, not a okay. Just want to make sure that subsequence is not sub-array. I've been messing that up lately as well, just a few times. So reading is kind of important. Okay. Oh wait, did I miss something? The difference is negative, positive or negative. Okay, so so the numbers do matter. My fault. I thought that. For some reason, I just thought I yeah, I don't know. I missed the delta part, so I still misread it, but only like for 10 seconds, so 20 seconds. So it's okay. So okay. So basically, you're trying to go up and down and up and down and up and down or something like this, right? Okay, and the follow-up is, can I solve this in linear time? So basically, so my first instinct is just basically dynamic programming, right? And you can do with n as you go to 1,000, dynamic programming is going to be probably fast enough. You do some n square thing where this would be the biggest or the longest sequence in a DAG or something like that, and there's like a or largest longest path in a DAG. Longest path in a DAG is going to be n square in a way, in a without any context or without any like observation. That alone will give us an n square and a correct solution. Now, can we get O of n, right? O of n probably requires some observation to make it a little bit better. If I want to aim for O of n, and some of this is a hint knowing that there is an O of n solution, I might try to do two things, right? Or a couple of things. My ideas are greedy, so I am solving this live. I clearly obviously don't know it yet. Though I do have the n squared solution in the back of my head, but if I need to. But yeah, my idea is maybe greedy will figure it out. Two is some kind of stack-based mono stack type situation. Because for every number, we're basically, I mean, we can think about it from the dynamic programming solution, right? The longest path in the DAG is that for every number, I know that I hand waved over that part a little bit, but for every number, you draw a DAG to the previous number, and then there are two graphs that you can do it with, or not two graphs, sorry. There's a dual, right, where you're reaching the current number. Let's say we have, all right, let me just put it here then. Going over the n squared solution real quick. Let's say for some number, we draw a DAG to a previous number if there's two versions of the 9, say, right? One is where we get to the 9 and then the next number we want it to be increasing, or we want the next number to be decreasing, right? And of course, in that case, if the next number is increasing, that means that the previous number is decreasing, and so forth the other way around as well. So that means that for the here, we can draw a DAG to the previous one. Let's say we have a 9 that is, 9 next number is increasing. That means that the previous number is decreasing. That means that there's an edge from 9 to 4. And from 1 to 9, right? So that's basically the idea behind this behind the n square solution. Can I do an O of n? So one thing that I would try to think about is, given all the numbers that are smaller than 9, take the min of all those numbers, right? Or sorry, take the max of the or not the max of the value, but the max of all the numbers, all the things that are inside that number, right? So I think we can do it with a mono stack, maybe. let's see, right? Let's say we want the numbers increasing. So I think for that kind of thing, we're trying to figure out the invariant, right? So here we have, for example, I think one thing that I'm not super clear about is, let's say we have something like 1, 4, let's say 1 is equal to 1, of course, and this is kind of like longest increasing subsequence almost from here. 4 we have a, 2 we have a 4, and then 3 we have a 9, right? And then now let's say we have a, now let's say we have a 3. Okay. I guess we do 3 here, and then we do a binary search, right? So I guess in that sense, actually, yeah, I mean, I think this is now just, of course, the two, you have to do both, and then you have to alternate them and look tracking them. But now I think we reduced the problem from O of n squared to n log n by converting this to LIS, right, which is longest increasing subsequence. And as I said, this is DP, of course, and of course there's an O of n log n solution, which we kind of have hinted at here, but I'm not going to go over that today because that's still not O of n, right? Also in that case, some of this is a little bit meta in that if that's the case, I feel like medium's a little bit too easy for it, or like too low of a rating for it. It's harder than a medium, maybe. Okay, so is there something even better? It's that, so we want an increasing, so we want something that's whatever, and even here, right, we moved to 7, but maybe that's okay. I mean, that's still gonna be n log n. I don't know that, and I don't know how the stack based solution would work, because let's say we have 1, 4, and 9 on the stack, and then now the 2 comes in, the 2 erases it, but then let's say we have another 10 next, right? Well, the 10, we actually want the 4, 9, and 10. So I don't know that the stack would work. So if I have to guess, and some of this it's cheating in the sense that I'm working from this, working backwards from the solution. Otherwise, to be honest, I probably would have been, 1, happy with the n square, and then maybe even happy with the n log, well, definitely happy with the n log n. But O of n, I think we have to maybe make another, we have to make some sort of other, another observation or something like this, right? Yeah, I'm trying to think about the linear solution for this one, and for those of you who might be joining me a little bit late or skip forward. I don't know that I have one, but if you are looking for an n square or n log n, we kind of have it. We haven't implemented it, but let's see, right? Yeah, there's subforms. How would you? So the max is going to be, I don't know, I mean, maybe there's a greedy thing that I'm not aware of, but linear time, and I hope that this isn't a linear time based on the fact that the thing is linear sorting or something like that. I'm not gonna lie, I'm blanking out a bit. Hmm. Don't know that I know this one. No, to be honest. Uh. Oh, I guess there is. I think I'm just overthinking it a little bit. Because I think there is another dynamic programming thing where. Can I prove it though? Because basically the idea here is that looking at the four, let's say we're going downwards, right? Well, if we're going down, then that means that, well, that means that our longest streak is going to be down, or we just take the previous one, skipping this number, right? Does that make sense? Hmm. Let me see. I mean, I think I have the idea, to be honest, but I'm trying to think about how to explain it and how to prove it. Because basically the idea is almost like this idea of like digit DP, right? Is because the things I have here are easy to prove for me. So that's why I would gravitate. But maybe you have something like for for previous, current, and again, you know that I like doing this though. Maybe only for competitive. For real thing, don't do it. But yeah, so that you have something like longest is equal to 0, maybe 1, but whatever. Maybe yeah. And then current is equal to 1 just because you always have one sequence, right? And then here, rather maybe that's not it. Maybe what we want is best positive, and then best negative, right? And maybe they're both 1 actually, and then we don't need the longest. And then here, then you can represent them in terms of, you know, like if the current one is bigger than the previous, then what do we do, right? That means that we want to increase the so best negative is equal to the previous best positive plus 1, and then the best positive we just kind of ignore it, right? We just keep on going. And then else if C is less than P, then we do kind of the same but opposite. Maybe this is even wrong. Maybe I typed it too fast, to be honest. Best positive is going to be best negative plus 1, and then best negative, right? By skipping this number. Is this right? I might have the signs wrong, but and then we just have to return max of best positive and best negative. But I feel like, so that's my intuitive sense. But I definitely feel like if you're at home and you're like, what is Larry doing? How is he explaining this? You're not wrong. So I'm trying to think about it a little bit. Is this right? Okay. But 824-day streak. Let me gather my thoughts a little bit to kind of explain this. But first of all, this is dynamic programming. And the way that I would maybe think about it, instead of writing it this way, is maybe we could rewrite it really quickly. Because the way that I would write it a little bit is, let's say get max last digit is positive, or last delta is positive, say. Yeah, and then you have index, and then you also say have another one get max last negative. Okay, I think I'm going to do a prove it by code, so I don't know. So then now we want to return max of get max where the last number is positive of n minus 1, get max last negative n minus 1, and n is equal to length of nums, obviously. So here, if index is equal to 0, we return 1, right? Yeah. And then that means that what does it mean when the last delta is positive, right? When the last delta is positive, then we want to look at the previous one that is negative, right? So there are only two scenarios, right? So basically we have two numbers, right? So previous number is equal to num sub index minus 1, say, and current number is equal to num sub index. And then now if the current number is sorry, friends. I got an emergency message, and I don't like to cut away. So if you watch that, sorry about that. But yeah, so now we want that if this is true, then yeah, let's see. Best is equal to 1 because we always have at least one item. If this is the case, then what happens, right? Then we want to take the current max or get max of last negative, because now that you go to the, so now we want to add an edge to it, oops, right? And then now else if the current is bigger than previous, then what happens, right? Well, if that's the case, then here we just, oh, I see. Okay, I think there was a part that was missing, right? So if this one number is bigger than the previous number, then positive of index minus 1, right? And then just return best. Maybe this isn't even the right code, but now I understand the logic. So I think this is the part where, to be honest, and this is very slow, but it's very easy to kind of go into your intuition. At least for me, I lean on experience to kind of feel out but I had trouble understanding why this was the case. So the reason why this is the case is because, let's just have an example, right? Let's just say you have an example where you have one, actually just like this one, right? Whatever. Let's say we have this case. Let's say we are here. So the last number, so we want to look for, okay, maybe actually here, because then the last number is a positive and then we're going here, right? So that means that we're looking for a previous number. And there are only two cases, right? Let's say this is a 2. Well, what does that mean? Well, okay, let's say this is a 7. What does that mean? Well, that means that this is the case. And because this is the case, we could just continue the streak. And then the other example is that this is smaller, right? Well, we cannot continue the streak for obvious reason, but we can inherit that streak. What I mean by that is that, so let's say at this 1, 2, right? You have this streak of 1, 2. And then in a greedy way, what we're doing now is taking the 4, okay, we say, okay, the 4 cannot add it here because then it's not a Waco subsequence, but in a greedy kind of way, 4 can be here, right? So you basically replace the 1 2 with a 1 4 here, and that's basically the idea behind this other logic which we had from the other solution as well. I'll bring it back up real quick. I'm really slow today, so I'm a little bit distracted. One of my good friends is visiting me from abroad and keeps on messaging me like panicky I'm lost in New York situation, so and so it's a little bit timely, my apologies, but hopefully, so with this insight, that's basically what this code does. I am going to expand this out and go over the how to do the dynamic programming part, but this is really most of it, to be honest. And of course, the thing that I would say is that now you have to add memorization and stuff like that, but this is really the idea, right? So now this is last one is negative, so we want it to be positive, so we have something like this. Did I mess this up? I might have messed this up actually. Last negative here, and then oh yeah, because we inherit the logic is the same, but then when you inherit the last thing, it would have to be negative. So that's why this is the case instead of positive. Sorry, I basically going just to be a little bit clearer, just to do it again. Basically, if you have a case where you have 1 2, what we did is we converted to 1 4 with a 4, and now we're looking for the last number to be decreasing, right? So that's basically what you're doing, and the next number is decreasing as well, because now the 4 is now the peak instead of the rally, right? So that's basically the idea here. So yeah, so usually I will do this, but I think today there's a lot of things going on. This is the solution that I recommend, but with the explanation that we talked about overriding or over-inheriting, and this is basically that code written in a different way. Let me just run it real quick. Of course, this is going to time out for bigger ends because this is not cached, and of course, maybe I have a typo or something. Let's see. If the previous is greater than here, maybe I made the signs wrong. Maybe I have the signs wrong. If it is tricky to kind of get right now that I'm just confusing myself. And to be honest, I'm a little bit rushing it because I'm trying to deal with this issue. But okay, maybe I'm just wrong in here, but mostly due to either typo or something like that. So I apologize if this video is a little bit yucky, but I think the solution is to look into here, and then the idea that I would talk about is just like I said, if you have one, why you are able to. Maybe I had it right the first time. Maybe I confused myself a little bit actually by writing it. Well, it's too bad. I think I removed it by accident. So yeah, okay. But the idea is still that let's say if the last number is increasing, then you basically want to use this to replace that number, but keeping its either rally or the top or the bottom. So that's basically the idea. I know this video is a kind of yucky. Sorry about that. I really got to run. Usually I have better time setting, but this is long weekend and stuff like this. Everything's chaos. So that's all I have for today. Let me know if this explanation is good enough for you. If not, ask some questions in the comments. Come to Discord, ask some questions. Happy to answer it. I'll see you later. Stay good, stay healthy, to good mental health. Take care. Bye-bye.